All right, you're welcome to another class on this in this statistic class. And is today's class is going to center on what I call correlation and regression analysis by hand. That is, you want to see how we can use our hands to do the calculations on correlation and regression. And likewise, we also want to see the researcher insights and the education hypothesis. I will be explaining them one by one. So we actually want to unlock the powers of the correlation and regression without relying on the computer. I know we have a lot of statistical package we can use to perform correlation analysis and regression analysis, but we want to see how we can do that without using computer. So also in this video, we also want to see how we want to walk you through a kind of step by step through the principles, the formulas, and the logical foundation that are behind of the most essential tools in quantitative research. So whether you are a student or an educator or you are an emerging researcher, this video will definitely help you. And likewise, we are going to learn a lot of things in this video, or let me say in this class. We want to know what correlation really measure in human behaviors and educational outcome. We want to see the difference between the positive, negative, and zero correlation. We also want to see the educational meaning behind strong versus weak relationship, how we can compute Pearson manually using the raw data and deviation scores, how we can also formulate and test basic educational hypotheses using handwork correlation, then how we can also do a kind of a simple regression, simple linear regression conceptually, then some of the step-by-step manual calculation for regression in the areas of slope, intersection, and then regression equation. So those are those things we want to do in this class. So I want to, okay, thank you very much. I can see, because I actually want to confirm if you can hear me clearly. So before we go into our calculation, I want us to quickly look at what correlation and regression analysis is. We said correlation and regression analysis are the statistical techniques used to study the relationship between two or more variables. And they will help us to understand whether the variables are related, how strongly they are related, and how one variable can be used to predict another. I'm going to cite an examples of that. For instance, let's say you want to talk about correlation, let me say correlation tell us how two variables moves together. That's exactly what correlation is all about. It tells us how two variables move together, the strength and the directions of their relationship. That's what correlation is all about. That's just the simple meanings of correlation. It tells us how two variables move together. It's just like when you are doing something, if an event is occurring between two persons now, yes, how they move together, their strength and their directions of relationship. That's what correlation measure. But regression tell us how one variable affects or predicts another. So the other one is the correlation is talking about the moving together of two variables, while regression is telling us how one variables affect or predict another. So I'll just tell us some of the key types you must understand in the areas of correlation and regression. And I'm going to look at that from the researcher perspective. I know you might have been using some of these things, but I want us to look at it from researcher perspective. So number one is that when you are determining whether the relationship exists between two academic factors, that's correlation. you are determining whether relationship exists between two academic factors. Or you want to measure the strength, how strong or direction, either positive or negative, of a relationship. Or you want to build predictive model for decision making. Or you want to validate theory or test educational intervention. That is when you can make use of correlation and regression. So invariably in practice, the first thing you just have to do is to first of all collect the data, clean the data, make sure that those data you collected, they are clean, explore the pattern you want to use, then you run your statistical test. Then from there you move to interpretation, interpret the coefficient and use findings to support policy or class decision. So there are quite numbers of what is it called? Correlation and regression. And I quickly want to run us through that before we go in details into this. And like I said, when you are talking about correlation and regression, like I said at the beginnings of the class, that when you are talking about statistics, it's basically divided into two: the descriptive statistic and then the inferential statistic. So the question now is, you want to know where did correlation and regression, where did they fall? Under what category? Yes, of course. I want to know in the comment section. Let me know in the comment section. Is correlation and regression descriptive or inferential statistic? Can I get that in the comment section? In the comment section, can we get that? Correlation and regression, is it descriptive or inferential statistic? I'm waiting for you in the comment section. Is it inferential or descriptive? Someone is saying both. Yes, thank you. Olusoji said it's inferential statistic. Yes, like I said, it's an inferential statistic. So, and then some of the calculations that fall under correlation and regression analysis, I'm going to tell us. And that's why I said in the definition that it is used to determine the strength and the direction of relationship between variables. So some of the calculation under correlation and regressions are Pearson correlation, Spearman rank correlation, simple linear regression, and multiple regression. So as far as this class is concerned, we are going to touch both the simple linear regression and the multiple regression. So correlation and regression analysis they are categorized into four: the Pearson correlation, the Spearman rank correlation, and then the simple linear regression and multiple regression. So those are the correlation regression. So let's look at some of the type. Like I've said, let's look at some of the type, because I've seen some people that are giving me another definition entirely. So let's look at the first one. Probably at this juncture, I'm going to quickly share my maybe I will share my screen so that you see some of the diagram that I've put together for you. So the first one we are going to look at here is the Pearson product movement correlation. Pearson product movement correlation. The Pearson product movement correlation measures the strength and direction of a linear relationship between two continuous variables. It measures the strength and the directions of a linear relationship between two continuous variables. Or we can say the Pearson correlation measures the strength and the directions of a linear relationship between two continuous variables. Let's take, for instance, maybe you want to look at height and weight. You want to look at the two variables there, the height and the weight. You know, they are two different things. Someone may be taller than the other person they have more weight than the other person. So you want to compare the two. Is the height determine the weight of an individual? So at that moment now, you are going to get two data. You are getting the data, the height of that person, then the weight of that person. So that is two variable. So when you measure it, if the height of that person is let's say 3.5, let's say 4 point something feet, the weight could be 60 something kg. That's for the first candidate. You move on to the second candidate, you move on to the third candidate, you move on to the fourth candidate, and you continue getting their data like that. So what you are trying to measure there is that you want to measure the strength and the directions of that two variable, that is the height and the weight. And the Pearson correlation, the value can range from negative to positive, either -1 to +1. So if it is +1, that is perfect positive relationship. That means the relationship that exists between the two variables is what? It is perfect positive relationship if it is exactly +1. If it is -1, it is perfect negative relationship. And if it is 0, that is non-linear, that is no linear relationship. That means they have no relationship at all. I want us to look at it from researcher experience. Let's just take a question. Let me just put a questions in the comment section. Let's say an educational researcher is typically applying a Pearson correlation when working with numerical data, such as maybe you want to talk about test score, attendance rate, study hour, student motivation score, or the researcher want to check an assumption such as the linearities and the normal distribution before running the analysis. So what you are trying to do in that place, and the best tools you can use is to use the Pearson correlation. So when do we use it? When do we use Pearson correlation? We use Pearson correlation, like I've said in the definition, to quantify how closely two variables move together. You use Pearson correlation to what? To quantify how closely two variables move together. How closely they move together. Because you know it's run between positive to negative. So if it is +1, it's going to be perfect positive. If it is -1, that is perfect negative. And if it is 0, that means it has no linear relationship. So we use Pearson correlation to quantify how closely two variables will move together. We also use it to determine the linear relationship. Number 3, it is also used to detect whether increase in one variable are associated with increase or decrease in the other variable. Like I've talked about the height and the weight the other time. So when you measure it together and you later get +1, that means it has a perfect positive relationship. If you get negative, that means you have a perfect negative relationship. But if you are getting 0, that means there is no linear relationship between the two variables. So that's why I said it is used to detect whether increase in one variable are associated with what? Increase or decrease in the other variable. So I'm going to give you an hypothesis that you can get, and you can make use of Pearson correlation. Let's say, for instance, if you are given a null hypothesis that there is no significant relationship between student study time and their mathematics achievement test. Let me drop that in the comment section so that you follow me. Let me drop that in comment section. Can you see the null hypothesis? I've just dropped that in the comment section for you to see. That's a good example when you can use Pearson correlation. That's when you can see that in the Pearson correlation. There is no significant relationship between the study time and their mathematics achievement. Study time and their mathematics achievement. So that means you might have categorized their study time. whether 1 hour, 2 hours, 3 hours, 4 hours, and their mathematics achievement. That is the null hypothesis. So the alternative hypothesis will be there is significant positive relationship between the student study time and their mathematics achievement. Of course, when we talk about the mathematics achievement, that means you have a kind of question, a mathematics question that you are giving to the student to test their academic mathematics achievement. So at that moment now, before you talk about the question, probably before the question, you might have told them that their study time, how many hours do you use to work mathematics in a day? Some may say 2 hours, some may say 3 hours if they do their calculation, some may say 4 hours, and you are using that to determine their academic achievement. So you now give them question now to solve. By the time they solve the question, each student, this one say, okay, I use 4 hours to work mathematics in a day. And when you find out the student achievement test, you find out that such student gets 15 out of 20. You move on to the second person, you collate the data like that. When you use Pearson correlation now, you are now going to use that one to take a decision at the end of the day. So that's one of a good educational, a good hypothesis that you can use to run the Pearson correlation. So let's move to the second type. The second type, that is the Spearman rank. Spearman rank correlation. I'll talk about the Spearman rank correlation. The Spearman rank correlation. That's the second example. Please, if you can still hear me clearly, let me know. Can we watch this video after? Oh, so we can. So just let me know if you can still hear me clearly. Of course, the essence why we are using this platform is to make sure that the recording is available even after the live class. After the live class, you can come back and watch the video at your convenience time. So, but it is better when we are doing it together like this, so that it will make it interactive. If you have any question, you can ask during the live class, so that we carry ourselves along while the class is moving on. So let's move on to the second one, which is the Spearman rank correlation. The Spearman rank correlation. So the Spearman correlation measure the strength and the direction of monotonic relationship. I'm going to define that, monotonic relationship. The Spearman correlation measure the strength and the direction of monotonic relationship between variable using rank or ordinal data. 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 Please, if you get that, let me know if you get that. If you get that, let me know. Or if you can hear me clearly. If you get that, let me know. Yes, okay. That's the reason why I said if you get that, let me know. So like I said, a Spearman correlation measures the strength and the direction of monotonic relationship between two variables. It measures monotonic between two relationships. I'll put it in the chat for you so that we get that. So I said the Spearman correlation measures the strength and the direction of monotonic relationship between two variables using rank or ordinal data. So what is monotonic? Because I know majority of us may want to know what is monotonic. What is monotonic? What is monotonic? So when we talk about monotonic, it's simply referring to the relationship between two variables in which the directions of the relationship is consistent, even if the rate of the change is not constant. it is consistent. It is consistent. So let's say a relationship, when we are talking about a monotonic relationship, it's talking about as S increase, Y constantly increase as well. As X increase, Y constantly increase as well. I'm going to give you an example. Let's say for example now, a monotonic increase is just like more study hours, higher test score. More study hours, higher test score. So the higher the study hour, the higher the score of the student. So that is a monotonic increase. And it could also be a monotonic decrease. Let's say the lesser study hour, the lesser your exam scores. Maybe you use 2 hours to study now, and you get 5 out of 20. You use 4 hours to study, you get 10 out of 20. Do you get that now? So that is a kind of monotonic increase. And in that the same direction as well, it can as well be what? Be decreased. So why is it matter? It is matter in Spearman ranking because we use it to do a kind of a ranking data, and it is also a non-linear relationship. So I think I've just tried to define a monotony because I know people will be looking at it that what is that? So Spearman correlation measure the strength and the direction of monotonic relationship between two variables using rank or ordinal data. So I'm going to be talking to you. Let's look at it from the angles of as a researcher. A Spearman rank correlation is statistic that help you to understand how two variables change together. Like I've said, that's monotonic relationship. How two variables change together, but it's not using rank or ordinal. A Spearman rank correlation is a statistic that help you to understand how two variables change together, but is using what? Rank or ordinal. In the ways when you are doing the ranking, you see that is going in line with that. So it's not like a raw number. So you are not using your raw number. You are using your ranking. I'll show that when we get into the practical aspect of it. And a very simple examples of that is what I've just done now. Let's say the first student. Let me put it in the comments. Let's do something in comments. Let's say the first candidate, candidate one. The candidate one study hour. Let's say the study time is 2 hours. The study time is 2 hours, and the scores of that student is let's say the scores of the student. Okay, let's say the scores of the student is 5. Let's say the scores of the student is 5 out of 20. That is the first candidate. We have another candidate, candidate 2. Candidate 2 spent candidate 2 study hour. Candidate 2 study hour 4 hours, and he went ahead and gets 10 out of 20. Are we together? So let's say candidate 3 spend like study hour for study hour, maybe he spend like 3 hours, and he's getting let's say he's getting 12 out of 20. So, and the data keep increasing like that. So when you now come back to Spearman ranking, you have to rank. So among the candidates 1, 2, 3, your ranking could be in ascending order. It could also be in descending order. Let us say we are doing the ranking in in ascending order now. Of course, you know, when we are talking about ascending, we are talking about from small to what? To highest. So when we look at this now, if you want to give them position, who use the highest study hour? Who used the highest study hour among the three candidates? That's why I said I want the class to be interactive. Who used the highest study hour? Thank you. That is candidate what? That's candidate 2. Candidate 2. So in that place, the position of candidate 2 is what? Is first. Yes, thank you. Omojumo, candidate 2. So candidate 2 is the what? In ranking, in terms of study hour, candidate 2 is what? Candidate 2 has first. So what is the position of candidate 2 in terms of score? In terms of score, that is second. That is second. So when I want to talk about the ranking now, we can say the study hour, in the areas of study hour, candidate 2 is what? Is first. Is first. And in terms of what? Score, candidate 2 is what? Is second. Do we get that now? So that is how the ranking will go. So that means we are looking at the studies hours and the what? And their score. And you do the what? And do the ranking. And do the ranking. So let's come back here now. So what that one is trying to say is that the Spearman rank is what? Is a statistic that helps us to understand how two variables change together. But it does this using rank. We look at how the variable change together in terms of ranking or order. So not the raw data. So you are not using the word, the raw data. So what do we measure? What does it measure? What does Spearman rank measure? It measures the strength of the relationship. It's measuring the strength of the relationship, how closely two variables move in a consistent pattern. How two variables move in a consistent pattern. Number 2 is that the direction is also looking at the direction of the relationship. It's looking at the strength of the relationship. It's looking at the direction of the relationship. It's looking at the direction of the relationship in terms of whether the variables increase together positively or the other way around, negatively. So that is what Spearman ranking is measuring. The Spearman ranking is measuring the strength of the relationship. It's also looking at the direction of the relationship. So why do we call it rank correlation? Why do we call it rank correlation? Why do we call it rank correlation? And you are, as you can see in the example that I give the other time, that when you are doing the ranking, you actually want to see the strength in the what? In the relationship. So when do we use Spearman rank? When do we use Spearman rank correlation? When the data are not normally distributed. We use Spearman ranking when the data are not normally distributed. This means that the data do not follow a bell-shaped curve, which is common in real-life educational setting. Then we also use the Spearman rank data when the data are ordinal. You know, I've talked about if the data are not normally distributed, we use Spearman ranking. We also use Spearman ranking when the data are ordinal or rank in order. And examples of that in education or as a researcher in education is that when you are looking at the student class position, for instance, now, let me ask this question. Let's say you want to give, let me ask the question in the comment section. Let's say you want to give a student position. Somebody gets 77. Another person gets, second candidate gets 65. The third candidate gets 65. Another candidate gets 45. Then another candidate gets 78. So what will be their position? What will be their position? So that means we have 5 students in the class. You have 5 students in the class. The candidate with 78 is the first position. The candidate with 77 is the second position. Now come and look at it now. The candidate with 65, the 265, they should have been the third position and the fourth position. But by virtue of getting the same thing, they will both share the what? The third and the what? They will both share third position. So that means the candidate that got 65, the first 65 and the second 65, they were both third position in that class. So that means in that class, there won't be fourth position. You just move to the fifth position. So the fifth position there now is what? Is the candidate that got 45. I hope that is clear. So that when we get into the calculation, especially in the areas of ranking. So that means 78 first, 77 is second position, 65 is third position. 65 is third position. Of course, you know we have 265. So the second one, that one to be what? Will be third position. And the candidate that got 45, there won't be fourth position now, will now be the fifth position. Is that clear now? So that is how to rank. Clear? I want to know if you can still hear me clearly. I want to know if you can still hear me clearly. So the example we use in education is that we make use of, anytime you make use of student class position, you are using Spearman ranking, you are using ranking. Or maybe you are using the Lakers scale. The Lakers scale responses to the questionnaire. You say strongly agree is 4. Agree is 3. Disagree is 2. Why strongly disagree is what? Is 1. I'll talk to you in the comment section as well. We have 3 things in the Lakers scale. We have strongly agree, disagree, and strongly disagree. Maybe you don't get that one right, but I'm trying to tell you that for the first time, that's what? That the strongly agree is the strongest, and it's going to take the highest score. It's going to take the highest score. So that means your strongly agree is what? Is 4. Agree is what? Is 3. Disagree is what? Is 2. And strongly disagree is what? Is 1. Can you see the ranking now? Can you see the ranking? That is in terms of what? Lakers scale. So then the last one in education is the ranking of school or teacher or performance level. Or performance level. So I will also be talking about, I've talked about the position. So let's just go to hypotheses now. Let's go to hypotheses now that are related to Spearman ranking. Maybe you have something like, there is no significant relationship between student motivation level. Of course, there is no way you want to measure the student motivation level except if you categorize that and their class position. So likewise, you will need to rank the motivation level, either low or medium or high. So likewise, the class position too, you have to do the what? The ranking. So that means their motivation level, you have to measure their motivation level. Probably you put it in 3 categories: low, medium, or high. Then their position, of course, you know their position. So if a candidate is having high motivation level and is getting like maybe fourth position in the class, the ranking will go in that order. So that's where you can make use of what? The Spearman ranking. So, and I'll give an example that there is no single relationship between student motivation level, which is going to be ranked, and their class position. So I'll put that in also in the comment section for you to see an hypothesis that can go with Spearman ranking. So that is where we are going to end it with both the Pearson correlation and the Spearman ranking. So now we want to move to simple linear regression. Like I said, there are two regression. We have what is called the simple linear regression, then we have what is called multiple regression. So the first one is simple regression, simple linear regression. The simple linear regression examines the effect of one independent variable. Or maybe before we go into this, if I may ask you, when you look at that question that I put there now, maybe we should even test ourselves. What is the dependent and the independent variable in that in that hypothesis that I just put down? Can you answer me? The hypothesis that I put in the comment section, what is the dependent variable there? What is the independent variable? Oh yeah, I'm waiting for you. I put it there. So what is the dependent variable there? There is no single relationship between student motivation level and their class position. So what is the dependent variable there? What is the dependent variable? Because it's very important. You must know that. Okay, without wasting much of our time, the student motivation level, that is the independent variable. The student motivation level is the independent variable there. Because this is the variable believed that it will influence or relate to another variable, which is the class position. That is, their motivation level will have influence on the class position. So motivation in that place now is the predictor to student performance or the student position, while the class position is the what? Is the dependent variable. You should be able to know something that can predict or that can influence the other one. That is the independent variable. The dependent variable is the one that you cannot change. Do you get that now? So the class position is the what? Is the dependent variable, because that is the outcome variable that the motivation level will determine. So we can also say it's also assumed to what? To change. The class position can also it's assumed to change, either improve or worsen. So it depends on the student motivation level. The student motivation level will be the one to determine the class position. So I just deliberately asked you that question, so that because it is very important for you to know. Yes, thank you. Adekunle said the student motivation is the IV. That is the independent variable, while the class position is the DV. That's the dependent variable. Thank you. I can see quite numbers of people. Yes, I think I have researcher joining me here. Yes, that's good. So let's go with that. So we're now moving on to simple linear regression. Like I said, the simple linear regression examines the effect of one independent variable on one dependent variable and predict the what? The dependent variable from the independent variable. I will help you in the comment section. The simple regression examines the effect of one independent variable on one dependent variable. Let's look at it from the researcher perspective. Let's say in an educational research, the simple regression is used when you are determining how a single factor influences student performance. So that means it must be single, because the researcher need to check the assumption, the linearity, the homoscedasticity of it, the normalities of the residual, then independence of the error. So the regression equation will help you to predict the future outcome, such as predicting the performance based on the study habit or based on the motivation level that I've used there. So when do we use simple linear regression? Why is it used? Why do we use it? Why do we use it? It is used to predict one variable using another. It is used to predict one variable on what? On another. It is used to predict one variable using another. It is also used to evaluate the impact or influence of a specific factor. When you want to know the impact of a specific factor. For instance, now we talk about motivation level. So we want to see that, can motivation level influence the student position? So the linear regression can also be used to build evidence-based recommendation. It is also can also be used to build another evidence-based recommendation. So I want you to just tell me, just formulate an hypothesis that you can use simple linear regression in the comment section. Can I have one? I'll give you one the other time. I want to see more in the comment section. So let me give you another one here. Let me give you another one here before we pick the last one. I want you to give me another example. So give me another example. Like I said, we are just going to spend more than 50 minutes in the class. So once we spend 50 minutes in the class, it's okay. So show me more example. Give me more example on simple linear regression. So I move to multiple regression now. So multiple regression. So I'm moving to multiple regression. So multiple regression, that one examine how two or more independent. Don't forget that simple linear regression is talking about one independent, one that predicts another what? Single dependent. But look at multiple regression now. A multiple regression examine how two or more independent variable, jointly predict a single dependent variable. So that means your independent variable must be two or more, and it's going to predict another single dependent variable. And like I told you in the physical class, that when we are talking about multiple regression, it could be relative effect or composite effect. When we talk about relative effect, it's talking about one by one effect. And when you talk about the multiple effect, it's talking about the combined effect. When you talk about the composite, it's talking about the combined effect of it. So let me talk from as a researcher. A researcher uses multiple regression when you are analyzing a complex educational system where multiple factors influencing the learning outcome. For example, you may want to investigate how teaching method, school environment, parental support jointly affect the academic achievement. So that means we are having three independent variables: the teaching method, the school environment, and the parent support, how they were affecting the academic achievement. So you may interpret each predictor coefficient to understand its uniqueness contribution to that. So why is it used? It is used to build predictive model involving a multiple variable. It is also used to identify which factors have the strongest effect. It can also use to control for confounding variable. It also supports policy decision and resources allocation. So I'm going to show you a very good example, aside from the one that I've give you the other time. You also tell me in the comment section, just tell me another hypothesis that you can use for multiple regression. Give me another hypothesis that is going to be on multiple regression. I'll give you another example here. I said there is no what. I'll give you another example in the comment section. Check another, aside from the example one that I give you the other time, you can also check it in that place to see. Yes, I've given you another example. I said maybe you are investigating how teaching method jointly affect the academic achievement. Three independent variable, how is affecting the academic achievement. So you too, give me also another examples of an hypothesis or a research or another hypothesis that you can use multiple regression in the comment section. If you have any question, it's time for question. I just have few minutes. I'm giving you a few minutes to ask question on what we've just discussed this evening. Question. If you don't have question, I will ask you question. Oh. I'm waiting for your questions in the comment section. I'm waiting for you. Yes. I can see that some of you are dropping questions that has to do with. So, guys, thank you, Yusuf. He said effect on motivation, self-concept, and interest on student academic achievement in secondary school. That's a good one. We can use multiple regression to do that. So, ladies and gentlemen, I really want to appreciate you. If you are joining here for the first time, you can try to subscribe to the channel, like the video, and also make sure you share the video with any researcher or any student that you think this video can support in their research journey. So once again, good evening, everyone. And till I come your way again, I am Kayode Adewale. So thank you all. Good night.